Hello dear students. Okay, so this is current divider formula. In this video I'm going to explain about the current divider formula. Okay, so current divider formula is basically applied in that case when we have two parallel two parallel resistors that are parallel to one another, so that the current I is flowing. Okay, now for example, if the current divides into two portions, so I1 is current is flowing through R1 and I2 is current flowing through the R2. So we need to find the current I1 and I2. We apply current divider formula. Sometimes why we learn this formula, because sometimes it is impossible to solve series and parallel circuit, so we need this current divider formula to find the value of the currents. Okay, so the formula is simple. So current in any branch is equal to opposite resistance or equivalent resistance or the total resistance in opposite branch, opposite resistance divided by same resistance in which the current is flowing, same R, plus again the opposite resistance, opposite R, and we multiply with the total current I. Okay, now I explain the circuit. For example, in the circuit we have current I that is flowing, so when the current reaches at this point, so it will divide into two portions. I1 flows through R1 and I2 flows through the R2. So we need to find how much current flows through R1 and how much current flows through R2. Okay, in order to solve, we use first we find the formula for I1. So I1 is equal to, so when we want the current through I1 through R1, so we need the opposite branch resistance. Opposite branch resistance is simply R2. Total resistance in opposite branch is simple R2, and divided by same resistance in which the current is flowing. So total resistance in same branch, that is equal to R, and plus that is equal to R1 plus R1 and plus the opposite resistance that is equal to R2, and we multiply with the total current I that is from the battery. Okay, that is I. Okay, so for I2 we need this formula. R1, the opposite resistance is R1, and divided by R2 is the same resistance plus R1 is the opposite resistance, multiplied by the I. Okay, so I solve a simple problem. So for example, if R1 and R2 has the values, okay, suppose simple solve, we use two values. For example, we have R1 is simply we have R1 is 20 ohm, so 20 ohm, R1 is 20 ohm, and R2 is 30 ohm. Okay, we need to solve the I1 and I2. So in order to solve I1, we use formula I1 is, so I1, in order to solve I1, so we use opposite resistance, that is 30 R2, divided by same resistance R1, that is 20, plus the opposite resistance again the 30, and we multiply with the total current I. Suppose the total current from the battery is, for example, 10 ampere. Okay, so that multiply with the total current, that is 10 ampere. Now we solve for I1, that is equal to 30 over 50 multiplied by 10, so we get 10 5. I1 is equal to 30 over 5, that is equal to 6 ampere. So the I1 is 6 ampere. Okay, now we solve for I2. So in order to solve for I2, we use opposite resistance, so I2. So R2 opposite resistance is R1, that is 20 ampere, 20 ohm, and divided by the same resistance, that is 30 ohm, and plus the opposite resistance, that is 20 ohm, and total current that is from the battery is 10 ampere. So I2 is equal to definitely it will be 4 ampere. When we solve, we get 4 ampere. Now you can see that when we add I1 and I2, we get 10 ampere, 4 ampere, so 4 ampere. So I2 is equal to 4 ampere. So 4 plus, so I1, total I is equal to I1 plus I2. You can check that. It's a quick check. I1 is 6 ampere and I2 is 4 ampere. That is equal to 4 ampere. That is equal to 10 ampere. So 6 plus 4, that makes 10. So this problem is solved. So simply we use this formula, current divider formula, in order to find the current through different branches that are parallel branches. Okay, so this is simple circuit R1 and R2. Now if we have a complex circuit having 3 resistors, okay, now we have 3 resistors R1, R2, R3, and the current through each resistor is I1, I2 and I3. How to solve this current divider formula again? So we suppose that now the value of the total current is again 10 ampere. Total current is again 10 ampere, and I1 and I2, I3 we need to find. So R1 we just assume the values. R1 is 10 ohm, R2 is 20 ohm, and R3 is 30 ohm. Okay, now R1, R2, R3, these are 10, 20 and 30. So we need to find the I1. So I1 is equal to, so first we need the formula. So simply formula, current divider formula is IN is equal to, again I read the formula, IN is equal to total opposite resistance. R opposite mean the total opposite resistance divided by same R, same where the current is flowing, same R, plus R opposite total resistance or equivalent resistance of opposite branch. Okay, opposite branch. So for I1 the opposite branch, so for I1 the opposite branch is R2 and R3. For I1, I again repeat, for I1 the opposite branch is R2 and R3. So first we need to find the R2 parallel R3, because R2 and R3 are parallel, so we need equivalent or total resistance R2 and R3. So R2 formula is R2 parallel R3 divided by R1 plus R2 parallel R3. Okay, so we can solve this one. So in other words, we can say that I1 is equal to opposite resistance our R1 same resistance plus opposite total resistance R. Okay, so I1 is equal to, so first we solve for opposite resistance. So opposite resistance R is equal to, so because opposite resistance is R2 parallel R3, so R2 parallel R3 is R2 multiply R3 divided by R2 plus R3. So simple, this is a simple formula to solve equivalent resistance. R2 parallel R3 is equal to R2 is equal to R2 is 20 multiply R3 is 30 divided by 20 plus 30, that makes 20 multiplied by 30 divided by 20 plus 30, that is equal to 12 ohm. So when you solve you get 12 ohm. Okay, so now we can find I1. So I1 is equal to, so that the I1 is equal to R2 parallel I2 12 ohm and divided by, so we also multiply with the source current I. Okay, so 12 over R1 is actually 10 ohm, and plus the opposite resistance is again 12 ohm, and we multiply with the total current 10 ampere. So now we get I1, that is equal to 5.45 ampere, that is exactly equal to 5.5 ampere, round off to 2 significantly. So this is I1. So simply for I1 we need opposite resistance R2 and R3 combinations. So simply R1 for R1 and for R2, sorry, next for R2, when we want to solve for R2, we need the opposite resistance of R1 plus R2, R1 plus R3, because these two are in parallel combination. So R2 parallel R3. So if you want to solve for I2, so we need opposite resistance divided by same resistance in which the current is flowing, same resistance R in which the current is flowing, and plus opposite resistance, opposite branch resistance, you can say that. Okay, and we multiply with the total current I. So I2 is equal to, so opposite resistance is, you know that R1 and R3 are parallel to R2, because we need to find current through R2, we use opposite resistance R1 and R3. So opposite resistance is R1 parallel R3 divided by same resistance, that is R2 and with the current I2 is flowing, plus opposite resistance R1 parallel to R3. multiply with the source current I. So first we need R1 parallel R3. So R1 parallel R3. Suppose R1 is 10 ohm. R1 is, we need to the values. R1 is 10 ohm and R3 is 30 ohm. Okay, 10 into 30. R1 is 10 ohm multiplied by 30 ohm divided by 10 plus 30. So we get the R1 parallel R3. 10 into 10 plus 30. We get 7.5 ohm. 7.5 ohm. Okay, now we put in the value I2 is equal to R2 parallel R1 parallel R3. So that is 7.5 ampere. 7.5 ohm. R2, the resistance in which the current we need to find. Okay, so R2 is 30. R2 is 20. Sorry, R2 is 20. 20 plus 7.5, the opposite resistance. Okay, we multiply with the 10 ampere. So we get I2 that is equal to 2.7 amperes. And finally solve for I3. So if in order to solve for I3, we need opposite resistance, the same resistance in which the current is flowing plus opposite resistance, and we multiply with the source current I. Okay, I3, in order to solve for I3, so for I3 we need opposite resistance. So the opposite branch resistance is simply R1 parallel to R2. Opposite resistance is R1 parallel to R2, and we divide with the same resistance in, that is R3 plus R1 parallel to R2, multiply with the source current I. Okay, so first we separately solve R1 parallel to R2, that is equal to R1 multiplied by R2 divided by R1 plus R2. So R1 and R2, that is equal to 10 into 20, 10 multiplied 20 over 10 plus 20, that gives us 6.67 or 6.7, round of two significant figures. Okay, now we put this value in I3. So I3 is equal to R1 parallel R3, that is 6.67 divided by R3. R3 is 30 plus 6.67, and the total current, source current I, the source current is 10 ampere, the current from battery. So we solve for I3, that is equal to 1.81 or 1.8 ampere. Okay, now if we add all these currents, I is equal to I1 plus I2 plus I3, we must get the total current 10 ampere. So 10 ampere. So I1 is equal to, we know that the I1 total current, quick check. Okay, quick check is I1 is 5.5 ampere. 5.5 ampere. 5.5 ampere. And I2 is 2.7 ampere. And I3 is 1.8 ampere. So we check the 10 ampere is equal to 10 ampere. So a quick check, for example, the total current will be the same. Okay, so in order to solve, apply this formula. So I write again the quick current divider formula is simply, so current in any branch N is equal to total opposite branch, total opposite resistance divided by same resistance in which the current is flowing, in which current I flows, plus again total opposite resistance, total opposite resistance. Okay, thank you, hope it works. Okay, thank you.